So today we're going to be jumping into lesson 4.6, and we're going to be talking about inequalities, what they are, and how we can write inequalities. So first, let's start out with what an inequality is. So an inequality is a mathematical sentence that contains 4 different signs. There's less than, less than or equal to, or greater than or equal to. And the signs that we use look like this. We have our less than sign, we have greater than, less than or equal to. If something's or equal to, we add a little straight line underneath it. And then we also have greater than or equal to. So those are our 4 inequality signs. And when we use inequalities, this means that we have an infinite amount of solutions. Infinite amount, of solutions. So before, when we were talking about solving equations, we really only had one answer, one solution. But in this case today, we're going to be noticing that there are going to be multiple or an infinite amount of solutions for different scenarios. So let's try one out. So example 1 says, how can you write an inequality to describe the ages of the children who must be accompanied by an adult at the sledding hill? And what we see here is it says children under the age of 8, so underneath the age of 8. So let's first list out, I'm going to draw a number line. Let's list out, if we're starting at 8, what are some ages that the kids could be if they have to be accompanied by an adult? How old could they be if they need to have a parent with them? So if it's saying under 8, they could be 7, 6, 5, 4, 3, 2, 1 years old. We can even go down to 0 because technically we could have like 6-month-old or 8-month-old. So basically what this is saying is that all of these ages right here beneath 8, even like 7.5 years old, all of these ages, these kids have to be accompanied by a parent. So we no longer just have one solution. It's not saying a 7-year-old has to be accompanied by a kid. It's saying all of these different 0 all the way up to 8 has to be accompanied by an adult. And so this is where our inequalities come into play. And so now we can say, so the age of a child, if they are less than 8 years, they have to be accompanied by an adult. Now, if this sign says children 8 or under, if we said children 8 or under, now we're including 8 years. Before we were only including what was beneath 8, but now we're actually including 8. So now we want to add that or equal to, because even if they are 8 years old, they have to be accompanied by an adult, where before it was saying under 8, so all the way up to like 7.5. But now we are including that 8. All right, let's try another one. Example 2, use a number line to show some of the ages of people who do not need to be accompanied by an adult. So remember in that first sign, it was saying, we said any age underneath 8 has to be accompanied. So they have to be accompanied by an adult. But now it's asking us to use a number line to show some ages of people who do not need to be accompanied by an adult. And then we want to write an inequality to represent those ages. So let's start at 8 down here this time, because we know it's not going to be underneath 8. So people who do not need to be accompanied by an adult, we have 9, 10 years old, 11, 12, 13, 14, 15, 16, and the list goes on and on and on. So now, what would our inequality for this be if we're saying anything over 8? Anything over 8. So we're saying if they don't have to be accompanied, their age has to be greater than 8 years old. And they don't have to be accompanied by an adult. All right, let's try another one. So example 3. So for all 4 of these, we want to first write inequality, and it's asking us to plot 5 points on each number line to represent the situation. So let's start with A. The length of a piece of wire, L, is longer than 20 1/4 foot. So it's saying it's longer, so L is longer or larger than. So you want to say L is greater than 20 1/4. So let's think about some points that we could put. So if it's longer than 20 1/4, we could say it could be 21, could be 22 1/2, could be 24, and it could be 23. I think we need 5 points, so then it could also be, let's just say 22. All right, B, the number of students S is at most 30. The number of students S is at most. So when it's saying at most 30, it means it could be, the number of students, it could be 30, but it can't be 30 1/2, it can't be 31, it can't be 32. So we're saying S could possibly equal 30, so we're going to include that or equal to. But it can't be 31, it can't be anything greater. So we're going to say it's less than 30. So that means 5 extra points. That means we could have 25 students, we could have 26, we could have 27, 28, and 29. All right, C, the cost of pizza, C, will be at least $8. So the cost of pizza C will be at least. So when it says at least, it means it could equal $8. It could cost us $8. So we're going to include that 8 in our solution. 8 could be a possible solution. But it could also be greater than. If it's saying it's at least something, that means it could be 8, but it could also be 9. It could be $9.50. It could be $11.50. It could be $13. So we want C to be greater than $8. So whenever we are including or equal to, we're saying that that number is a possible solution. So before up here, our 20 1/4 was not a solution because it had to be longer than 20 1/4. It could be 20 1/2, 20 2/4, but it had to at least be longer than 20 1/4. Whereas in this case, we're saying it could at least be, 8 could be a solution. All right, last one, D. Zoe's age Z is not 11 years old. So let's think of some possible solutions. If it's not 11, she could be 14. She's not 11, she could be 12. But she could also be 7, 9, 10, or 6. So when we're saying something is not, she can be any single age besides 11. So what we're going to say is she does not equal 11 years old. She's not 11 years old, which means that she can be any age other than that number, other than 11. All right, so the last 2 questions, I want you guys to try these on your own. So I want you guys to write an inequality to represent each of these situations. So number 1, Harry is taller than 60 inches. And B, or number 2, Sherry is not 4 years old. So if you guys need to draw a number line on your paper and list out possible solutions to help you write this inequality. Are we going, is it going to be less than? Is it going to be greater than? Or is it going to be or equal to? I want you guys to try to write these situations as an inequality. All right, so A, let's check our work here. So if A is saying Harry is taller than 60 inches, I'm just going to use H for our variable, but you could have used any letter. Harry is taller than 60 inches. 60 is not part of the solution here because he has to be taller than that. So it's not an or equal to, so he's just going to be taller or greater than 60 inches. And then our last one, Sherry is not 4 years old. So remember our last one that we did, if she wasn't 4, she could be 6, she could be 5, but she could also be 1 or 3 or 2. So I'm just going to say Sherry is not 4 years old.